Hi, this is Professor Cummings, and I want to bring you a video today. So I'm going to deviate a little bit from what I've done the last few weeks, which is, looking at mechanics. And now I'm going to go back to some calculus problems and give you a few examples. These are some that I think we needed in a class that I was teaching over this semester, and I think it would be helpful to others that might need it. So basically all I'm doing is I got like 4 problems here, and they're all going to be u-substitution type problems. And we've gone through them in class. So what I want to do is basically show you the substitution, how we're going to do that substitution, and then work through the problem from that point forward. So I think if you want to get the most out of this video, be prepared to stop the video and work through the problem yourself first. See how you do, see what you understand of it, and then restart the video, and then look at it as we go through the problem. All right. So again, here's the initial problem. Y is equal to the antiderivative of x cubed times the quantity of 2 plus x to the 4th raised to the 5th power dx. So go ahead and pause it now and work on it yourself, and then unpause it when you're ready to start again. All right, so one of the first things we're going to do is when you do u-substitution is you have to find the term that you can take a derivative of in order to make the substitution happen. In this particular case, you have in parentheses 2 plus x to the 4th, and if you take that, and the whole quantity is raised to the 5th power, if you take the derivative of what's in that parentheses, you'll have just a 3x dx. So we can do a substitution on that because, you got the power difference of 1. So you're going to get a derivative of this, but you will have a constant left over. So let me put this into a pen. So these are the exponents. And, if we do that derivative, we'll be able to see how that'll make a good substitution. So here I'm going to take u is equal to 2 plus x to the 4th. Then we're going to take that derivative of u, so du on the left side, and it'll be the derivative u on the left side and the derivative on the right. So that comes out to du. The derivative of this is 4x cubed to the 4th dx. So again, you can see this derivative here. Du is going to equal to, but there's a problem with having this constant, so we're going to have to divide both sides by 4. So we're going to have this constant of 1 over 4 when we do this problem, but that shouldn't be much of an issue. So 1/4 of du is equal to x cubed dx. So now we can substitute back in and we have a much easier problem to integrate. So now we have the integration of 1 over 4 times u to the 5th du. So that's that 1/4 of du has been substituted for this. And u to the 5th, this is u raised to the 5th power. So this isn't too tough. Now you look at it this way, which is the whole point of u-substitution. The 1/4 comes outside the infinite sum. And then we just use the power rule to do the rest of the integration. So y is equal to 1/4 times the integral of u to the 5th du. Now we apply the power rule. So add 1 to the exponent and then divide by the new exponent. So that's 1/4. Add 1 to the exponent, so 5 plus 1. And then divide by the new exponent, which is 5 plus 1. And plus c. So when we go through the arithmetic, you have 1 over 24 times the quantity of 2x to the 4th. This is our original value of u, raised to the 6th power plus c. And this is our answer. All right. So that's one problem of u-substitution. So you can see again, you find something with the difference of 1 in the exponents. Take the derivative of that. And if you have a constant, you have to divide both sides by the constant. and then you can do your substitutions. So let's check out another one. So here you have y is equal to the antiderivative of 1 over the quantity of 1 minus 6t raised to the 4th power dt. So go ahead and pause that, try it on your own, and then you can start the video and see how you did. Okay, so now let's look at this. We've got no t value in here, but you have 6t raised to the 1st power. Now, there is nothing in here as far as implying a t, so you can just basically assume, or not assume, that t to the 0 is 1. There's an implied 1. So when we do this u-substitution, we're going to take that whole quantity of 1 minus 6t and take its derivative. So that comes out to du is equal to a negative 6 dt. All right. Now we're going to have to divide both sides by negative 6 because we do have that constant. So 1/6 of du is equal to dt. So when we do the substitution, we're going to be substituting this for 1/6 of du, and this 1 minus 6t will become u. So now this is a lot more easy to integrate. The negative 6t comes outside the infinite sum. You can also just go ahead and change this from 1 over u to the 4th to u raised to the negative 4. Now you apply the power rule. So add 1 to the exponent, divide by the new exponent, in which case it's going to go from negative 4 to negative 3, divide by negative 3. And then add your constant of integration. So now you have the original constant 1 over 6, negative 1 over 6, times the negative 1 over 3, which will be a 1 over 18. And u raised to the negative 3, and substitute your original value of u back for u. So you have 1 over 18 times the quantity of 1 minus 6t raised to the negative 3 plus c. And you can change this and make it a more acceptable format. Since that is a negative 3, make it 1 over 18 times the quantity of 1 minus 6t raised to the 3rd power plus c. Now let's try another one. So here we have y is equal to the antiderivative of x squared times the quantity of x cubed plus 5 raised to the 9th power dx. So keep in mind our exponents when we try to look what's going to be our derivative. So go ahead and pause it. Work on this on your own and then come back. So when we look at this and we do our derivatives, we're going to use the u value of x cubed plus 5. Then we can take its derivative. The 5 goes to 0. We end up with 3x squared du. So du is equal to 3x squared dx. Now, we do have a constant there that wasn't in the original equation, so we're going to have to divide both sides by 3. So 1/3 of du is equal to x squared dx. So now we can go back and do our substitution. Y is equal to the antiderivative of 1/3 of u to the 9th du. Now let's see, the 1/3 comes outside the infinite sum. Then we just apply the power rule again. So add 1 to the exponent, divide by the new exponent. So we end up with 1/3 times 1 over 10 times u raised to the 10th power plus c. So we do the arithmetic. 1 over 3 times 1 over 10 is 1 over 30. And back substitute the value of u, which was this x cubed plus 5. And we have that plus c. Now we have one more. And this one is going to be an interesting one. Here you have the antiderivative of e to the x times sine of e to the x dx. All right, go ahead and pause this and give it a try and see how you do. All right, so this one is going to be interesting because now you're dealing with base E problems. And one of the things that are interesting about base E is its own derivative. So let's go ahead and check this one out and make it for u substitution. So in this case, we can take u as e to the x and take its derivative as du is equal to e to the x dx. So this is a clean substitution, no constants at all. So du is equal to e to the x dx. So e to the x dx, that's going to be substituted out for du. And e to the x here will be substituted out for u. So we have something that's fairly simple to integrate again. Antiderivative of sine of u du. Now, the sine of u is just the negative cosine of u plus c. Now we back substitute for u. We end up with y is equal to the negative cosine of e to the x plus c. So this is Professor Cummings. Thanks for watching. Go ahead and like, comment, ask any questions in the comment section. Definitely like it and share this video, especially if you're in a class with somebody who might need some help in their calculus with u substitution. And I will see you in the next video.